What's up, guys? We are going to look at multiplying and dividing rational expressions. So hopefully by the end of the video, you can multiply and divide rational expressions just using some basic multiplication and division rules. So a lot of what we're going to look at today, you've actually already done before. We're just going to do it with rational expressions, meaning we have letters and numbers together in a fraction. All right, so fraction multiplication property essentially states that if we have two fractions and we're multiplying them, we just multiply straight across. So that's how you multiply fractions. So a over b times c over d is equal to ac, or a times c, over bd, or b times d. All right, so what are our steps for multiplying algebraic fractions? Essentially what we want to do is we want to factor all numerators and denominators. Next, we're going to multiply by applying the fraction multiplication property. So basically, we multiply the numerators together and then the denominators together. And then our last step, we're going to divide out any common factors. All right, so we're just going to jump right into some examples because that's the best way to learn is just by doing. So um, we are going to multiply everything together. So um, I can multiply 4 times 25. Well, on this first one, if I'm trying to factor, if I'm following the steps, 4a squared b cubed, there's nothing you can factor out of this because there's nothing in common for every single term. You have a 4, an a squared, and a b cubed. Can't do anything with that. 15x to the fifth y cubed, again, same problem. I can't take anything out. There's nothing in common. And then this one and this one, the same thing. So the reason I'm jumping straight to step number 2 is because I can't factor the numerator or the denominator of either one of these. So, okay, so 4 times 25 is 100. And then a squared and b cubed, and then x to the fourth, y squared. So I couldn't multiply any of these together or combine any of them because none of them have the same base. So remember when we talked about properties of exponents, we can only add the exponents when we're multiplying if they have the same base. All 4 of these are different, so we can't add any of those. All right, the denominator, we can multiply 15 times 16, which is 240. And then I have a times b times x to the fifth y cubed. Again, same thing, can't combine any of them. I like to write it in order so everything is matching up right on top of each other so you can move things around because it's multiplication. From here, you're going to start to simplify what you can. What can I cancel out? And what you should be asking yourself is what is the same in the numerator and the denominator that I can cancel? So obviously 100 divided by 240, you can simplify that to 5 and 12. And then you can start canceling out what you can. So I have a squared in the numerator and a in the denominator. So I have 2 here and 1 here. So I'll have 1 left, and it's going to be in the numerator. Next, I have b cubed over b. So I have 3 on top, 1 on bottom. So I'm going to have 2 left, and they're going to be in the numerator. Move on to my x's. I have 4 in the numerator. I have 5 in the denominator. So I'm going to have 1 left, and it's going to be in the denominator. And then the y's, you have y squared over y cubed. So you have 2 on top, 3 on bottom. That's going to leave you with 1, and it's going to be on the bottom. So you have completely simplified this expression. All right, moving on to number 2. So for this one, we're going to start with the first step because we can actually factor some of this stuff. And so if I have 10x squared minus 15x, what do these two terms have in common? Remember, terms are separated by a plus or a minus. So 10x squared and 15x, I can take out a 5x from both of them, and I would be left with 2x minus 3. Remember, if you were to multiply it back, you would get this back. All right, let's see if we can factor the denominator, 12x minus 8. Well, 12 and 8, what do they have in common? Hopefully you know they have a 4. So I have 4 times 3x minus 2. All right, times, and then I want to see if I can factor this one. 3x minus 2 There's no number that will divide into 3 and 2 evenly, so this one doesn't factor, so I just have 3x minus 2. And then the denominator here, we have 20x minus 25, so I've got 5, and I would be left with 4x minus 5. All right, so now everything is factored, and now that everything is factored, I can multiply straight across using my fraction multiplication property, or basically I know how to multiply fractions, so I just multiply straight across. So I've got 5x times 2x minus 3 times 3x minus 2 over, I've got 4 and 5, so I can multiply those together to give me 20. And then I have 3x minus 2 and 4x minus 5. All right, so now that I have multiplied everything across, I'm going to simplify by dividing out all the common factors. Basically, what will cancel? What do they have in common? So we have 5x and 20. Well, 5 and 20, you can simplify that, 1 and 4. And then you have the 2x minus 3. That's not in the denominator, so I can't cancel that out. But I have 3x minus 2 and 3x minus 2. So basically, if you see it in the numerator and the denominator, you can cancel it out. And then my 4x minus 5, I can't cancel that out. So my answer would be 1x, or just x, times 2x minus 3 over 4 times 4x minus 5. And voila, that is it. There's your answer. So pretty simple, straightforward. If you see it in the numerator and the denominator, you can cancel it out. And then obviously you can cancel out numbers if they're pulled out from parentheses here. All right, the next thing we're going to look at is dividing. So we have to take a look back at what the reciprocal is. So reciprocal of a fraction is the fraction created by interchanging the numerator and denominator. Basically, you just flip it. So some examples, if we have x over y, the reciprocal would be y over x. We're just flipping it. C squared. Now, I talk about this all the time. If you have a whole number or something that's not a fraction, you can make it a fraction by putting a 1 under it, which makes this really easy to see, oh, the reciprocal is just 1 over c squared. And then b minus 5 over y, the reciprocal would be y over b minus 5. So pretty easy. You just flip what the numerator and denominator, they change places. So we're going to use that when we're dividing rational expressions. So you might remember when you learned how to divide fractions, something along the lines of keep, switch, flip, keep, change, flip. I don't know. There's lots of different acronyms, but essentially you keep the same. The first fraction stays the same. The division sign becomes multiplication, and you flip the second fraction, and then you use your multiplication rules by multiplying straight across. So essentially, division is like the multiplication, with the exception we have to change it to a multiplication and then flip the second fraction. And then we follow the same exact rules that we did before. All right, so let's look at this first one. Before I can simplify anything, I'm going to change this to a multiplication problem. So the first fraction is going to stay the same. And then this is going to become a multiplication, and I'm going to flip the second fraction. All right, so now you have a problem that looks like stuff that we just did on the previous slide. We are going to multiply. So first we're going to factor what we can. So what do they have in common? Can you take anything out? Well, if I'm looking at this top one, I have a and a squared, so I can take out 1a. And then I have b squared and b, so I can take out 1b. So what would I be left with? If I take out an ab from the first one, I'm only going to be left with b. And then if I take out an ab from the second term, I would have 4a. The b would be gone. All right, so that's factored. And then c cubed, I can't do anything with that, so I'm just going to bring it straight down. C to the fifth, can't do anything with that. But in the denominator, I have 4b squared minus 16ab. So 4 and 16 I can take out a 4. And then I have a b squared and I have a b, so I can take out 1b, and so I would be left with b minus 4a. So basically, your first step, factor out what you can. What do they have in common? Excuse me. All right, next up, we're going to multiply straight across. So I've got a, b, c to the fifth. I like to put anything that's been taken out of parentheses. I like to put that first and then do my parentheses. You can do it however you want, but I find that it keeps it in my brain. It's really easy to see everything. And then I like to go in order too because I'm a math geek, so it just makes sense to go in order of my ABCs. All right, so I multiplied straight across and this is what I get. Now what I do is I simplify what I can. What can I cancel out? All right, so if I start with A, I have an A up here, but I don't have an A down here. So A is going to stay. I can't cancel that out. I've got a B. I've got B and B. Well, that would cancel out, so I don't have B anymore. And then I have C to the fifth and C cubed. Well, I have 5 here and 3 here, so I'm going to have 2 left, and they're going to be in the denominator. Or, excuse me, numerator. And then I have a 4 here. And remember, that's gone, and that's a 2 now. So I have a 4. I can't cancel that out because there's nothing outside here that can simplify 4. So the 4 is just going to move over. And then I have b minus 4a and b minus 4a. So this is my simplified answer, ac squared over 4. Right. We have one more example. And this one looks a little more like what you guys are going to be doing on your practice stuff. So all right, division, same process, except this one, the first one's on a fraction, so I'm going to make it a fraction by putting 1 under it. Again, you can make anything a fraction by putting a 1 under it. So first step is we want to change it from a division problem to a multiplication problem. So keep, switch, flip, or however you remember when you were taught. All right, now it's a multiplication problem, and I'm going to follow my steps. So I want to factor what I can. So this first one looks like it's a simple ABC because the number in front of x squared is 1. So I have a binomial times a binomial. So what multiplies to x squared would be x and x. And then two numbers that multiply to negative 24 and add to positive 10. That would be positive 12 and negative 2. And then I can't do anything with 1, so I'm just going to bring it down. And 3x minus 36, well, I can take out a 3, and I would be left with x minus 12. And then in the denominator of x squared minus 144, hopefully you're looking at this and you remember your difference of squares. So remember, this is a perfect square and this is a perfect square. So this is going to multiply, or not multiply, factor to x plus 12. Oh, that's a bad 2. Every single time. 12 times x minus 12. All right, so now everything is factored. I'm going to multiply straight across. So I've got x plus 12. Oops, I forgot my 3. Again, I like to bring out my numbers or letters that I pulled out first. So don't forget to do that. And then x minus 2, and then x minus 12. So basically just multiply everything in the denominator or numerator and then multiply everything in the denominator. So 1 times anything is whatever you have, so I don't have to write the 1. X plus 12, x minus 12, and then I want to cancel. What do they have in common? Well, x plus 12 I can cancel out, x minus 12 I can cancel out, so I am left with 3 times x minus 2. And voila, that is my answer. Now, one last thing I want to go over, I know it's not in the directions, but on your practice, it's going to say state the restrictions. So restrictions are basically what can you not have. If you think of this, this is a division problem. So before we canceled these guys out, we had x plus 12 and x minus 12. Now, we know that we cannot ever divide by 0. So when we want to find the restrictions, we're just going to take what's in the denominator and set it equal to 0. Oops, I'm jumping ahead of myself here. That's minus 12. And then solve for x. So x equals negative 12 and x equals positive 12. So your two restrictions that you can't have, x cannot be plus or minus 12. So make sure on your assignment portion that you actually do that restriction part. What can it not be? And again, you do that before you get to the final answer. So you're going to go back here and say, okay, what's in the denominator? Set it equal to 0, and then those are the things that x cannot be. All right. Well, hopefully you found this pretty simple and easy. Write down any questions that you have and bring them into class. All right. Peace, people.